Okay, well, after Colin's operating on Q100 DATV, which we've still got the slide up for now, we're now going to move over to Rob M0DTS, who's going to talk about the all-digital approach he's taken on the refurbishment of GB3KM. And I think this is really the way we need to see repeaters go in the future. So Rob, thank you for agreeing to talk to us. Take it away.
Thanks, Dave. That's really good. Okay. So yeah, this is just a little talk on GB3KM. We've been doing upgrades for quite a long time now. It seems like that. I think we started them back in 2014. We decided to do some new upgrades. So I'll put a few slides up and I'll show you where we're up to. Okay. So yeah, it's sort of an all digital repeater, but as you can see there, there's a little asterisk, not quite. So yeah, back in 2014, we had a bit of a brainstorming session, and this is what came out of it. Ideas for what we can do, what we can upgrade, and lots of little things. Funnily enough, it's all based around a Raspberry Pi, which seems to be quite a common theme. Lots of inputs and outputs to control things. DTMF, lots of sensors for monitoring PAs and things like that, and hopefully the way forward. So yeah, quite a bit of development work went on with that. Did a bit of designing, knocked up a few PCBs to test out the ideas and things. And in the end, we made up some PCBs, which is the first for me to do. So it was quite a good experience to get to that point. So yeah, quite a long progress. That was about, I think, when was that? 2018. So yeah, 2 years ago, I managed to get some PCBs made up. So it took quite a while, but there we are. Right. So basically, what's new? What have we added into KM? So there's a new logic control unit. This replaces a 16F84, which is getting a little bit dated these days. But that came from a design from GB3KM and Jason G7KM back probably 2005, 6. So yeah, a big upgrade. We're adding 2370TX with the new NOV. This is going to use the Pluto and the 264-265 encoder box. We've added HDMI, a new switch. So basically we're going into the realms of HD or thereabouts. We needed a lot more audio stuff, so a new audio mixer, a bit extra control on the amps and monitoring and things, and because everything's going kind of network connected, a new router, or a router. We didn't have one before. So this is the new logic control box. We've got a Raspberry Pi in the top here. This is the main one. It controls basically everything on the repeater. Power supplies, as a UPS. This one has to be under control of everything at all times. So there's a UPS here. If the mains drops out, that keeps the Pi happy. The middle board here is it's got more of the analog stuff on, but analog sync detectors, 8 of them. Well, an 8-way switch and a single sync detector. A on-screen display chip. DTMF receiver chip, and a real-time clock for the Pi to keep everything in sync. The right-hand board here is just lots of digital I/O, so there's 48 digital I/O there to cover everything we should ever need to do in the future, hopefully. All the control on the Pi is in Python code, pretty much, and a bit of code for the a web GUI to kind of control all the settings and things like that. I'll show that a bit later. So the audio was quite a tricky one that we had to deal with. We needed lots of inputs and outputs, and we needed it all to be controlled by the logic. So the Pi would tell it what to do, which audios to switch in and out and things. So in the end, after a lot of chit chat, we decided to make a new mixer unit. And there was a few designs before this came up, or ideas, but this one basically uses a load of cheap ADC and DAC boards from the usual suppliers, and an FPGA to glue it all together, which sounded quite complex, but I was kind of up for a challenge at the time, so we ended up using the FPGA to join it all together. So the features on this is we can squelch noisy analog signals. That's done in DSP. We can basically connect any input to any output, or any combination of inputs to any combination of outputs. And this comes in when we want to do duplex operation through KM, where we say we've got two users. Each user's audio gets muxed to one goes to the left channel, one goes to the right channel, and then on the user's receiver, they would select the opposite channel to theirs. So when you're operating on KM, you only hear the other person's audio, not your own. That's okay for two users. Once we get above that, we're still looking into how to cover that one. But lots of possibilities there, and we have the possibility for repeater linking and streams. Apologies there. Repeater linking and streams to mute the input stream from getting repeated out on the output stream. So hopefully no feedback. Okay, so that's what it looks like inside. At the top there, we have 3 stereo digital analog converters. We've got the FPGA dev board in the middle, which hasn't changed at all. Most of the stuff's off the shelf in here, apart from the 2 breakout boards for the analog to digital converters over here. So there's 6 stereo analog to digital converters, which bring the audio in or from the back. And yeah, all the mixing gets done in code inside the FPGA. There's a VU meter on the front, and a PA, a little headphone PA on the side there for the sysop. So video, we've gone to HD now, so HDMI video switch. Took a little bit of time trying to source something that would do what we wanted to do. This one gives us 9 inputs, which most of the ones out there seem to give 4, maybe 8 at times, and are quite limited to what you can actually do with them. So this one allows us to set any input to any output segment on the screen. So if it's a 4-way screen, we can specify which picture goes where and which pictures are displayed or not displayed. One of the benefits of that is we can hide the analog noisy signal coming in. We can hide that one off the screen, so it gives us more video bandwidth overall. We don't want to be encoding noise on the screen. So that's one of the good features in there. We're using at the moment it's a little bit of a bodge on the code. Apologies there. A little bit of bodge on the code. We're actually using the second HDMI port of the RIDE at the moment to display an EasyCap input. So we're kind of using the RIDE for multi-purpose. Analog composite to HDMI on converters that you can get from, say, eBay and various other places don't really do a good job on weak signals. So we're using the EasyCap input, which seems to do a good job for that. The encoder is the I don't know we don't really know what brand this thing is, but there's a few names mentioned, but it's just the H.264-265 encoder box. It's HDMI in, and we can control this through the network with a few scripts in Python and things from the Pi, so we can kind of control all the streaming and various other things on there. remotely, which has been quite useful. That all came about from the Pluto control with that. So, development's come along quite a bit with that. So yeah, on transmit, we're still using the MK808 with the PVR and DigiLite on 3.4 gigs. This has been running for about 6 years now, I think, which is very surprising. We didn't expect that MK808 to last that long. So yeah, this is upgrading to a Pluto with the encoder. The Pluto's got a Ethernet adapter on, so we can connect it through the router from the encoder box. So the video and audio stream from the encoder comes across the network into the Pluto. I don't put too much detail in about the transmit side here, really, because at the moment it's just on 23 centimeters. Hopefully in the future we'll build up a mixer unit so we can convert from 23 SEMS up to 13 SEMS and 9 SEMS and 10 gigs, and basically use the same RF for all the outputs that we're using. We don't know how long a Pluto is going to last on 24/7. I don't know whether anyone's actually tried that yet. We've been running them quite a long time, and they seem reliable so far. And the last kind of main thing that we've added is something to monitor all the sequencing, controlling of PAs and switching things on and off. So yeah, we needed a new way of controlling everything rather than just a relay. So we wanted to have a bit of extra monitoring, so we monitor temperature and forward reverse power to antenna and things like that. So this is what we came up with, completely custom design, using the Arduino just because it's nice and easy to use. Again, daisy chain quite a few of these around the repeater for the different amps. We are in different locations. We can switch PAs on, the PAs on and off. We can monitor temperatures. We can monitor power supply voltage, or if the PA's got a forward and reverse power, we can use that. So that's for monitoring. There's a little screenshot of the kind of web config of the repeater. On the left here, shows input ports, output ports. The bottom here is input ports, so we can see we've got analog sync detector and then a few inputs on just general GPIO pins. We can give them names and things and tell it which audio channel on the mixer we're going to be using. We can add new inputs there, basically on the fly, pretty much. The logic basically is telling it which video output for which input. So that's kind of like the matrix of how it works, and we can disable inputs or things like that. There's the kind of control for the transmitters, whether we've got a beacon at time period and then an operating time period, and say whether the sync, if there's a signal active, does it activate the repeater and things like that. This is still work in progress, so there will be more to come. We've got just a basic audio mixer GUI there to control the levels for that as well. That's a little picture of the rack, how it's looking here at this end for the development. So the control unit at the top there, the new mixer, video mixer, and then the audio mixer at the bottom there, and the router. So yeah, quite a rapid run through of everything there. So yeah, you can watch my live development on the BATC stream, and also thanks to BATC for the bursary funding for some of the equipment.
That's brilliant, Rob. That's a really good run through, and it's great to see such innovative development, even FPGAs there. That's well beyond anything anybody else is doing. And good to hear the old MK8 and PVR and DigiLite still going. I've still got one of those that works as well.
Yeah.
So no, really good run through. And Rob, of course, is another one of our testers who contributes and tests all the stuff we do. So thanks very much for that, Rob.
No problem.
You mentioned bursaries, and that will bring us on to our next talk, which is from Noel, BATC Secretary, talking about bursaries after a short pause. Thanks, Rob. All the best.
Thanks.